Okay, so now we're starting with Newton's third law of motion, right? So can anyone give me a rough idea what do you know about Newton's third law? Yes, Mashal.
सर न्यूटन्स थर्ड लॉ इज दैट लाइक जब एक फोर्स
Yeah, sure.
मैं मशाल नहीं हूँ
Sure, speak up.
जी
I
सर
know you're excited,
तो
right?
जैसे
Yeah.
इट्स ओके जब एक सर अकर होती तो वो इट डजंट अकर लाइक इन सिंगल इट अकर्स विद अ रिजल्टेंट फोर्स एज वेल
Okay. Good. Okay, so Mashal also wanted to tell the answer. Mashal, you can go on.
So the third law of Newton states that every action has an
Mhm.
equal and opposite reaction. So when we apply a force on an object, that
Okay.
object will push or pull back with the same amount of force but in an
Mhm.
opposite direction.
Yeah, that's good, right? So iska I gave a very simple example, right? Let's just see the example. Let me show my skill, right? And let me just draw the ground over here, right? Okay, it's too big. This is the ground over here, and imagine this is the wall, right? Not imagine, just think that this is the wall over here, right? This is the wall over here, and this is Azan standing over here, right? Let me just make him closer to the wall. Let me make the wall correctly to just show the three-dimensional sides. Right, these are the walls. It's a brick wall, right? So Azan is basically, let's say, standing over here, and Azan wants to test his limits, right? Azan throws a punch. Azan throws a punch at this basically this wall, right? Let me just throw a punch. Okay, so he applies a force in this direction. So what happens, Azan, then? If you want to smash this brick wall, right? So what would happen to your hand? Yes, Azan. Azan is here or not? Is Azan here? Or are you guys just sitting out, right? Azan, am I audible? Hello. Okay. I believe I'm audible and okay, he's having some connectivity issues. He just okay, I guess he's trying to join from another device. Okay, so imagine this is Azan and he tries to basically apply a force, right? He tries to apply the force in this direction, okay? So what would happen, Vardha? Would he be able to break the brick wall?
यस
Yeah.
सर अगर वो
Yes, if he is a Superman, right? Yeah, obviously yes. If he is a Superman, right? So obviously he won't be able to crush this in real life, right? So why, if you just let's say zoom in over here, if I just zoom in over here, what would happen? This is the brick wall, right? This is the brick wall over here, and this is basically Azan's hand, right? And he's basically trying to smash this. So what happens? Basically, when you apply the force in this direction, okay? So the atoms inside this particular brick wall at this position, they are compressed, right? So they're compressed by little amount. So let's say he is applying a force in this direction, right? So the wall also applies the same force but in the opposite direction, right? Does that make sense?
सर
So
वापस रिपीट कर सकते हैं
yeah, I'm just saying, okay, let's say this is Azan's hand over here, and Azan is trying to basically he punches the wall with the force F, right? So what does it do? It basically, if I zoom in further, this is the wall over here, ठीक है? So इसके atoms थोड़े compress हो जाते हैं, right? Let's say these are the atoms over here, they are compressed, and let's say these are the atoms which are normally over here, right? So these are the atoms which are closer to this particular point of contact. So the atoms are compressed over here. So when they basically are having a force of F, so they are compressed. Imagine you're sitting on the sofa. Your sofa cushion basically compresses, right, when you sit down. So just imagine this: when you punch the wall, so the atoms are so basically squashed, compressed by very little amount, right? So then, as a result, they also pushes you back, right? Pushes the hand back to again regain your original position, right? So negative F means they're providing the equal but force in the opposite direction, right? Does that make sense?
Yes.
So we have a couple of
Yes.
force. One force is in this direction, okay, which was by Azan, right? And the other force is basically in this direction, which is a force of negative F. It is by the wall, right? So these pairs of forces basically explain the Newton's third law of motion, right? These pairs of forces explain Newton's third law of motion, right? So now let's go to the definition. Okay, now let's try to see. Okay, what are we trying to study? Okay, so now let's skim the first of all the steps one by one. Okay, so this is Newton's third law of motion, which states that force never occurs singly over here. That means that whenever you apply a force on an object, that exists always in pairs, right? Why is that? If you just see this example over here जो हमने बनाया, so when Azan applied a force, the wall also applied the force in a great direction. ठीक है? So there is a couple of forces. So forces exist in pairs. ठीक है? Okay. So for example, when you step forward from rest, your foot pushes backwards on the earth. Sorry. And the earth exerts an equal but opposite force on you, right? So imagine you're standing on the floor, right? Let me draw a foot. Let's say this is one of the foot over here. You're standing over here, right? So this is your force. So you're basically applying a force that is on from your foot to the ground, right? So the ground, the earth is also going to apply opposite force in the opposite direction, but of the equal amount. Okay. So that your foot is stationary over here, right? So always the forces exist in pairs. So this particular force is called contact force, right? Which you would have studied before in the first types of forces हमने पढ़े थे हमारे पास, ठीक है? So this is called a contact force, right? So then we have an example of the book over here, right? So let's see this example. What are they showing over here, right? So this is, let's say, imagine this is your physics book, right? This is your physics book, right? It's lying on your table, and you just basically finish studying, right? Now you're observing the book over here. You're observing the types of forces acting on the book, right? So can anyone identify the types of forces acting over here? It's already there, but can you just explain? Is it correct or not?
The gravitational force.
Gravitational force. Okay, how is it acting?
So the earth, like the gravity, I guess, pulls on the book.
Good.
और
And
फिर contact force भी है. जब
perfect.
book के साथ table के साथ लग रही है तो the book, I guess, applies force on the table. तो
Good.
table भी इस book पे लगाती है.
Good. Right. So yeah, she is correct. So first of all, we have one contact force which we have already seen, right? So this is the point of contact. We assume कि हमारे पास all the mass is at the center of the book over here. We assume that this is the center of mass. We'll see what is center of mass in a while. So what is happening over here? This is the push of the book on table, right? So the book is trying to compress the atoms near the table over here, around here, right? So what happens when they slightly get compressed? They also provide the opposite force, right? So they also provide then a push of table on the book, right? If it is F, this is also F, right? So they are equal in opposite direction. If you add it up, they will add up to 0, right? So if you add, let's say, these forces, they will have to add up to 0 newtons. That is the reason that the book is stationary over here, right? It is not moving. There is no resultant force, right? If there would be any resultant force, if your resultant force would not be equal to 0, then you can apply Newton's second law to basically get the acceleration with which your book is, let's say, falling down, or let's say it's being dragged. So you can find your acceleration using this formula, which we have seen in the last lecture, right? I hope it makes sense, right? Now, this is not just one pair of forces available over here. We have also the weight, right? So let's imagine this is the center of mass of the book. So this is the weight component of the book over here, right? What is the weight? It is just the pull of earth on book, right? So pull of earth क्या होता है हमारे पास? It is a gravitational force. It is a gravitational force, right? So that is also called as weight. So imagine similarly, say if your book is getting attracted towards the center of the earth, the book is also trying to pull earth towards itself. But okay, since the mass of the book is too small, let's say the mass of the book is, let's say, 1 kg, right? Imagine that it's a huge book. And the mass of Earth is 6.024 exponent 24 kg. It's huge, right? So there would be a force from the book to the Earth, but it would be pretty small, right? But there would be a force which is going to basically attract the Earth, right? So these are the pairs of forces which you can find on an object which is at rest. Okay? It can be a man standing, right? A man standing on the floor. So same couple of forces would be there, right? यहाँ पे contact force भी होगी onto the foot of the person standing, and there would be also gravitational force pair, right? So if everything is clear till now, give me a thumbs up. Give me a thumbs up if it is clear till now. Clear to Ruba, Hamza, okay, and also not to Maeve. What about Azan? Is Azan in the class, or he just logged in over here and he just is enjoying his snacks? Azan, are you here?
Yes, Rigiri.
Okay, so is it
Yes,
clear or not? Is it
Can you
clear? I
please
cannot
explain
hear you.
again?
Yes, Azan?
Can you please explain it again?
This part, this part or the definition part?
This
Okay, this one.
this
Okay.
light.
So Maeve also didn't give me a thumbs up. Maeve, what is unclear? Is this example unclear, or the definition of Newton's third law?
Just the definition.
Definition.
Yeah.
Okay. So definition of Newton's third law is as simple, right? Let me just write down the definition first, ताकि it makes sense. Okay. And let me write it down over here after this slide. Okay. Newton's third law of motion. Okay, so let's write down definition. I hope it will make sense after this. And let me choose this color over here. So it states what? To every action, there is an equal but opposite reaction. Right? Up. Let me just give you another example for that. Right? Imagine this is, let's say, Ali over here. Right? Ali goes to, let's say, his friend, right? Let's say Farid. And let's say, as a joke, Ali slaps him, right? Ali slaps him, right? So as a return of favor, he also got a slap, right? But in opposite direction, right? So you can imagine this. This is a couple of force, right? So when we discuss this example over here, imagine when Anas was trying to let's say punch the wall. So as when he was punching the wall, he basically applied a force F, right? Let me choose yellow highlighter. So he applied a force F on the wall, right? So as a reaction, the wall applied a force on his hands, right? That is force. Why is it negative? Because it is opposite in direction, right? So when to every action, so action was this was the action, right? The action was with the force F, and this is the reaction, right? From the wall to the hand, right? And the definition says that okay, to every action there is an equal but opposite reaction, right? You can see okay, the forces magnitude are same, right? It is also F over here and it is also F over here, right? So the magnitude is same, just the direction of forces or the action reaction are opposite in direction, right? So that is the Newton's third law. Does that make sense now? Maeve, give me a thumbs up if it makes sense. Okay. Azan. Acha, so this example was unclear. So whenever you have, let's say you have a book over here which is stationary at rest, right? Azan, do you know how does contact force acts?
What's up?
Do you know how does contact force acts on on an object? So यहाँ पे basically let's say this is the point of contact which is this, right? This cross, right? So now there is a push of the book on table, right? So कुछ force लगा रही है book on the table. Since as the atoms of this table are being squashed, ठीक है, imagine कि they are compressed by a very small amount. When they basically decompress, they will also provide the opposing force, right? So it's the Newton's third law, right? So this force is the action force over here, and this force is the reaction force over here, right? So they exist in pairs. Okay, the direction is the opposite, but the magnitude is same, right? So this vector is called the push of the table on the book, right? So this is the actions which was by the book on the table. This is the reaction which is the force by the table onto the book. Does that make sense?
Yes, sir.
Similarly, यहाँ पे let's imagine this is the center of Earth, right? This is center of Earth. So this is basically pulling the book towards the center of the Earth. That is also called the weight, right? So similarly, since the forces exist in pairs due to Newton's third law, okay, there would be always a couple of forces, okay, that forces would exist always in pairs. That is why we also have a vector which is basically being attracted towards this. So book is also attracting the earth by a force of W. The earth is also attracting the book towards the center of itself by a component of force that is equals to W Newton, right? ठीक है, I'm just saying कि the mass of the earth is so huge, right? And the mass of the, let's imagine the mass of the book is 1 kg, right? So if you let's say leave the book, if you have a book and throw it on your, let's say on your bed, you would see that the book is falling down, but you won't see the earth moving towards the book because जो mass का difference है वो बहुत huge है, right? So the majority which you basically see is the book will be moving towards the earth, right? इसकी डिटेल हम पढ़ेंगे बाद में. So how is this true? We will study this in astronomy and cosmology part. Okay, what am I talking about over here? So that's the couple of forces make sense. Okay, forces always exist in pairs. So whenever there is a book resting on the table, you will have two types of forces. That is a contact force and the gravitational force pair. If it makes sense, give me a thumbs up.